Okay, so let's look at more examples and understand this procedure clearly. First step you need to do is that you need to make sure your differential equation is in the form m times dx plus n times dy. Well, it's already in that form. So what is m? M is 2 times y plus 1 e to the x, and n it seems to be 2 times e to the x minus 2y. Now once you identify the m and n, what you should do is to test for exactness. So to do the test for exactness, you differentiate m with respect to y partially. So if you differentiate m with respect to y partially, you assume x as a constant. So that means what you get is 2 times e to the x, because derivative of y plus 1 is 1, right? Now partial derivative of n with respect to x, that is for again for test for the exactness. So if you differentiate n with respect to x, here you have x, so it's 2 times e to the x, derivative of e to the x is e to the x, and derivative of 2y is 0 because y is a constant. Okay, now both of them are equal, right? Okay, so we pass the test of exactness. We can proceed. Now at this point, what you can do is you can pick either m and m or n. So let's pick up m. So m by the definition is partial derivative of f with respect to x. Okay, so if m is partial derivative of f with respect to x, to find f we integrate m here being 2 times, let's multiply through e to the x to make our integration easy. So now we integrate, right? Okay, so if you integrate with respect to x, integral of e to the x is e to the x, so it's 2e to the x y, plus if you integrate 2e to the x, it's 2e to the x plus a constant. Now the constant here is a function of y because we assume y to be a constant. Okay, now we know f but only half of f because we don't know what is g. Now we know n is the partial derivative of f with respect to y. So we know already f, so let's differentiate f with respect to y and see what we get. So if you differentiate f with respect to y partially, this will be 2 times e to the x because derivative of y is 1. 2 times e to the x, derivative is 0 because there's no y terms, x is a constant. So if you differentiate g with respect to y, it's not partial, it's g prime y. You differentiate g with respect to y and g is only a function of y, so it's really not a partial derivative, it's the original derivative. Okay, now this supposed to be equal to n, right, by the definition. So what is n actually? The n is given to us is 2 times e to the x minus, let's distribute these two, so it's minus 4y, right? Minus 4y. Now if you compare these two, 2ex cancel out, so g prime y is negative 4y. Now we know g prime y, so to get gy, derivative of g is negative 4y, so to get gy we have to integrate 4y with respect to y. So if you integrate 4y, it's negative 4y square over 2 plus c. Now we can have a plus c because truly g is only a function of y and it's not partial, here it was not partial derivative, it's ordinary derivative. So gy is actually 4 over 2 is negative 2 here plus c. So our final solution is we got our f to be 2exy plus 2ex plus gy, here is negative 2y square plus c. Let's say c sub 1. So we can rewrite the solution making it equal to 0 because it's a constant. We can take c1 to the other side and we can say it's a constant. So this is the solution for the differential equation. Now one question that you might ask here is that why did I specifically choose at this point to start from m? we said that m is the partial derivative of f with respect to x, and then we integrate m with respect to x to get f. But can't we do it in the other way? We can do it in the other way also. We can start from n also. Let's say how we do it. So if you happens to start from n, well, we say n is the partial derivative of f with respect to y. So then really to get f, what we should do is we should integrate 2ex, this term, minus 4y with respect to y, right? To get f, if you happens to start with n without m, okay, but you should wind up with the same answer. Now if you integrate, your f should be, since you integrate with respect to y, here 2exy, remember this is a constant, here minus 4y square over 2, so it's actually minus 2y square, right? Plus a c. Now the constant is function of a x. Previously it was a function of a y because we integrated with respect to x. Now we integrate with respect to y, so it's a function of x. So this is our x. Now we use the fact n. Now let's use the fact m. M is 1. M is what? Partial derivative of f with respect to x. So let's take the partial derivative of f with respect to x that we found, because we want to find gx. To find gx, you have to find m. What is that you did not use for integration? Okay, for integration I used n, so to find gx I need to use m. So partial derivative of f with respect to x will be 2exy. If you differentiate this term with respect to x, it's 2exy. Here if you differentiate this term with respect to x, that's gone, plus g prime x, right? Now this is supposed to be equal to m. What is m? M is 2yex plus 2ex, right? So 2exy plus 2ex. Now this cancel out. What is g prime x? G prime x is 2ex. Okay, so we know the derivative of g with respect to x. So to get g, we have to integrate 2ex. So if you integrate 2ex with respect to x, what you should get? 2ex again, right? But 2ex plus c1. Now c1 is a constant. It's really a constant. Okay, so that is g. All right. So what is our final answer? So the f that we got from here is f is 2exy minus 2y square. Now here we get 2ex plus c1. So isn't this the same thing, right? We get the same thing, right? Okay, so no matter which order, which procedure you follow, you will get to the right answer. Okay. All right, so let me do another example, okay, slowly, so that you can make sense out of this. 8y minus x square y dy over dx plus x minus xy square is equal to 0. Okay, what do we have to do here? So here, first thing is we need to convert this into a term where it look like m times dx plus n times dy, but it's not here in that format. So let's multiply by dx, right, the whole thing. So we get 8y minus x square y dy plus x minus xy square dx is equal to 0. So I rewrite the differential equation to look like what we want. Let's switch the order because that is what we used to have dx first. So I can rewrite this so that it's comfortable for us. And from here we know that what is m? Well, we know our m to be x minus xy square, n to be 8y minus x square y. Okay. Now we need to test for exactness. So we differentiate m partially with respect to y, which will be negative 2xy, n partially with respect to x, which will be negative 2xy. So they are equal, so they are exact. Okay, so since they are exact, we know m is partial derivative of f with respect to x, n is partial derivative of f with respect to y. So let's pick m, because it seems to be like m is a simple function and you can pick any really. So f should be the integral of m x minus xy square with respect to x. Okay, so if you integrate here with respect to x, this is x square over 2 minus x square y square over 2 plus constant is a function of y because you integrated with respect to x. Okay, now we know n is the partial derivative of f with respect to y. N is 8y minus x square y. Now if you differentiate f with respect to y, the f that we got, it should be equal to this. So if you differentiate here partially with respect to y, this term goes away. This will be negative 2x square y over 2 plus g prime y. Now 2 cancel out, so we can simplify this. Let's write it down, negative x square y plus g prime y. Now this should be ideally n. What is n? 8y minus x square y. Okay, x square y cancel out. So what is g prime y? G prime y is 8y. Now we know the derivative of g with respect to y. So to get g, you need to integrate with respect to y. Okay, so if you integrate this with respect to y, we get 8y square over 2 plus c1. c1 is arbitrary constant. So 4y square plus c1. Okay, so we know what is g. We know what is f. F is x square over 2. We fill up the data with g. X square minus y square over 2 plus g is now 4y square plus c1, so this should be equal to 0. So your solution is over 2 plus 4y square. Let's take the c1 to the other side, a constancy, and this is our answer for the differential equation. So that is how we solve a differential equation using the exact equation method. Okay, all right, thank you very much.